Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's average level difficulty puzzle, and it's called Lying Whisper Loop by Yitrio. And here are the rules. Normal Sudoku rules apply, which mean place the digits 1 through 9 once each in every row, column, and box. Draw a one-cell wide loop of orthogonally connected cells. The loop may not touch itself, not even diagonally. So orthogonally just means that that cells share an edge. So you cannot connect the loop diagonally here. So this is not a valid loop. Oops, that is. But if you remove one of them, actually let's remove this one. Let's remove that one. This is no longer a valid loop. Even though it touches diagonally, they must be orthogonally joined for the loop. So that would be valid. In addition, the loop cannot touch itself. So for example, if we move that part here, that's not valid because that technically touches itself here, right? Obviously, you touch itself when you're crossing through a cell, but you cannot have an additional touch. Perhaps an easier example to see. Let me see if I can make one. Um, hmm. What about if we do... Okay. This is not a valid loop because it touches itself diagonally too. So diagonally or one additional touch orthogonally is not valid. So that's the loop mechanics. Okay. The loop acts as a German whisper line. That is, adjacent digits on the loop must have a difference of at least 5. So on the loop, if you have oh, that's actually very interesting. Not completely. Anyways, if you say you had a 1 on the loop, and it would say these two were the next parts of the loop, then you would have to have a 6, 7, 8, or 9 on each surrounding cell of the loop. And that's German whisper line. So the loop acts as one large German whisper line loop. So just remember that. Cells with the arrow clue may be either on or off the loop. If an arrow cell is off the loop, then the digit in that cell counts the total number of loop cells in the indicated direction. However, if an arrow cell is on the loop, then the digit in that cell must not correctly count the total number of loop cells in the indicated direction, not including itself. So, okay, so basically the arrow says, basically you ask you the question, how many of these cells are on the loop? And if the arrow cell itself is on the loop, it correctly counts the total number of loop cells in the indicated direction. However, if it's on the loop, then the digit must not correctly count the total number of loop cells in the direction. So say this was part of the loop. All of this was part of the loop. Since this is on the loop, it cannot correctly count the total number of loop cells in the indicated direction. So this one could not be 8. And then this one could not, since it's on the loop, it cannot be 7, etc., etc. Okay, so say we remove parts of this. Well, okay, that is interesting. Let's choose this. This cell indicates that would have to, since it's off the loop, it would have to basically count the total number of cells on the loop in this direction, in this specific direction. So that would not include that because that's not on the loop, but that would include all 5 of these. So then this would have to be a 5. On the other hand, this cell cannot total the amount of cells that it sees on the loop in this direction. So that would be 4 because it's those 4. So then this could not be 4, but it could be any other number. And then this one could not be 0, but that's fine because it could be any other number. And those are all the rules. Little difficult because you have the loop and the not loop, and plus I'm not used to this variant particularly. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. So either this is on the loop, which makes it a 1. Wait. Sorry, it's off the loop. Either this cell is off the loop, which makes it a 1 at most. But then that would have to essentially have something on the loop. So if this is off the loop, it must be a... First of all, it has to have a value, which means it has to be 1 at least. And they can only be 1 because there's only one thing it's pointing to. So if this is off the loop, this would have to be 1. And it would point to something that's on the loop. But then the problem is the loop would have to continue on to the 1 and then make that on the loop. So that cannot be off the loop. So that cell specifically has to be on the loop. And we don't know what it could be, right? So it could not go this way. So it cannot go here because these two would touch. So it must go this way. So the loop continues, has to go here. So there's at least 2 here. It could just continue all the way here, right? And then these are all just, not valid. What does that mean then? Okay. So we know it goes this way. It's either this way entering in, or it's this way entering in. So it could actually exit out this way still. Oh, that's interesting. These two have to be different. So they either both have to be on the loop. So it could go this way. Or you have to break one. One of them has to be on the loop. Right? Because either they point to this. So if both of them were off, they point to the same amount, which is not possible because then they would break Sudoku rules. So one of them at least has to be on. So one of these is on and could be both. So it could go this way. It could go this way. It could go this way. So one thing we know, well, it could go this way than that way. We know one of these is on the loop. We don't know which, though. Or both. So one of them is potentially valid. We don't know. We're going to mark the ones that we know cannot be in gray. Right, so if this one is, then it's fine. If both of them are, it's fine. If this one is, that's fine too, because then this would be some value. It'd be either 1 or 2. It couldn't be 2. It would have to be 1. Similarly, one of these two has to be on the loop, right? If neither of them are on the loop, then they both have the same value. So one of them has to be on the loop. Same here. One of these has to be on the loop. So one of these has to be on the loop. One of these has to be on the loop. At least. So it cannot... Interesting. Okay. So say this one was the one on the loop. We know we need to touch here. But if it goes this way and then somehow comes back, that touches itself. If it goes this way and goes back, that touches itself here. So this can never be on the loop. Therefore, this has to be the one on the loop. So that's green. It cannot go this way, so this cannot be on the loop. So we know actually this is 2 or 3. Because it sees 2 or 3 on the loop. This then has to go this way. So it has to enter here and it has to go this way. So it has to go this way. So then this could go like that, or it could go... Okay, so this has to enter here. So then this is not green. This is not orange. We know this has to be green. So it could just continue here or go further or whatever, but it just has to be, yeah. So this cannot be on the loop, which means we know this is on the loop, which we know that's on the loop. This is on the loop. This is gray. This cannot go this way because it would touch itself diagonally, so it has to continue here. So we know this is 3 specifically. This cannot be on the loop because it would touch itself, so this has to continue that way. So it has to go here. It must touch it, so it cannot go that. So this one has to be on the loop also. Right? Because one of these is on the loop. Say this was not on the loop, it would have to go here, but that's not a loop anymore, right? It just stops there then. So that's on the loop, which means these cannot... So this cannot be 1. This cannot be... So there cannot be a 1 here. There cannot be 3, but that's obvious because that's not 3. This cannot be 1, 2, 3, 4, 5, 6, so no 6. We don't know about this. This cannot be 1. So that can't be 1 either. We don't know how this works. This sees... So this can't be on the loop because it would touch itself again. This could go down. This could continue here. Okay. Oh, remember, they have to... The loop acts as a German whisper. Okay. Wait. I might have broken something. I must have made a wrong assumption because the problem is... Since we know this is a German whisper line, none of the lines on the loop none of the digits on the loop can be a 5. So we need a 5 somewhere in row 1. But according to my logic, this would have to be the 5. But then that has to be off the loop. But that's pointing to 7 digits that are on the loop, which does not work. So this is obviously... I made a bad assumption somewhere. I don't know where. So again, this has to be on the loop, because if it's not on the loop... Say it wasn't on the loop again. If this is not on the loop, then this must point to the total number of loop cells on it. So this would have to be 1 pointing to a loop digit. But the problem is that the loop would have to continue on into it. So that it has to be, so basically it has to be on the loop. So this has to be on the loop. It cannot go this way, so it has to enter that way. So that's valid. Oh, I think I see where I messed up. Okay, so it can't be this way, right? It has to continue here. Okay, I see what the assumption. So it had, okay, so we just proved that this doesn't work, right? So say it was this one, right? We know one of these two is. So assuming you cannot, okay, so first of all, you can't have both. If you have both, it just continues this way. But then this one of these two has to be touching this, right? Because if they both are off, they equal the same number. And so forth, there's a contradiction in Sudoku. So this cannot be both. So assume it's this one then, and then this one is not. This one then has to enter here and has to exit this way. This cannot go back here, so that it has to go this way. We know one of these two is, it can't go this way, so it has to go here. But then we run into the same problem again of where's the 5, right? So that doesn't work. So it cannot be this one. It has to be this one. So it has to go this way, right? So that means the Sudoku has to be this way, which, or the, sorry, not the Sudoku. The loop has to go that way, which means that can't be the loop. These both point to, so this can never be 4. Sorry, it can never be 5. So the 5 has to be one of these two. Right? Oh, not necessarily. Not necessarily. It just has to be not on the loop. We know this can't be 5. Okay, so this can't be on the loop. This cannot be on the loop. So this tells whatever it is. So this is either 3 or 4. This cannot be on the loop because of these 3. So this has to be 1 or 2. It has to be 1. It it could go that way. So that could be 1. Can this ever be 5? One of these has to be on the loop. Maybe both. The problem, okay, so if this is on the loop, sorry, if this is off the loop, and that's the 5. So say this was 5, and this is off the loop. You can only have 2 more on the loop here, which means you can't go touch and back there. So this can never be 5. Yeah, this can't be 5 on the loop. And same problem here, right? It has to go here and then touch and then go over, or go have just one value here and touch. And that doesn't work. So we know the 5 has to be one of these or one of these. We know one of these has to touch. So this one specifically has to be green, has to be on the loop. If it's not on the loop, how do you enter this one, right? So it could just enter this way. It could enter this way. So this one also has to be green, right? Because if it does go to this one, it has to enter this way. If it enters this, if it goes here, it has to enter this way. It can't go here and exit. Well, I mean, basically it has to enter this one. So this is connected. So 5 is either here or here. Okay. Where is, say this is, where can the 4 and the 6 be? So this could be 6. If this is not 1 and you have this. and then this would go up, and then this would be 3, and then this would be 5. But the problem is, okay, so let's try and go that way. So say this was a 6, right? If this is a 6, we know then, and this is not in the loop, we know this, that can't be in the loop. We know this would have to be in the loop. So that could be not be a 5. So this would be 5 and not in the loop, right? Because it goes down here. So this is not in the loop in a 5. Therefore, this is a 3. Where can the 4, I guess, no, okay, the 4 could be here. The 4 could be here and the 4 could be here. Okay, that's actually valid. Um, okay, so, okay, so say this was a 5. If this is the 5, and therefore it's not on the loop, this has to go this way. Which means this exit this way, which means this exit this way. So this could not be, okay. Um, oh, that's interesting. Hmm. Hmm. Okay. This sees two of the same, sorry, two unique digits on the German whispered line. So this is 1, 2, 3, 7, 8, 9. This will see two unique digits on the German whispered line because it either goes here or it goes here. So this is 1, 2, 3, 7, 8, 9. This will see 2, 3 unique digits on the German whispered line because it either enters here and goes there or enters here and goes there. So this is 1, 2, 3, 7, 8, 9. This will also see two unique digits on the German whispered line because it goes either here to here or just here to here. So this is 1, 2, 3, 7, 8, 9. So that's 4 already. We have a 3 and a 4. Say this was low, high, low, high, low, high. So, oops. Okay, so say we made this pink, yellow, or yellow, pink, yellow, pink, yellow, pink, yellow, pink. Is that always the case? I think so, right? Make that pink, yellow, pink, yellow, pink, yellow, pink. I think that's always the case then. So yellow, yellow, pink, yellow, pink, yellow, pink, yellow, pink. Yes. So one thing we know then is these 4 digits have to be the same entropy, I think is it. It's basically has to be the same high or low set, right? Oh, but we don't know about that one. So let's try this. So say this was pink, yellow, pink, yellow, pink, yellow, pink, yellow, pink. Okay, so this is always yellow and pink, and this is always pink, yellow, pink. So no matter what, then we have this distinction. So that's very interesting. That's very interesting. This has to, this has to end either here, in which case, well, that's yellow. Interesting. Okay. So say it enters back in here, right? This would have to be pink. And therefore we know the pinks would all be highs. So say it does not enter here. It just enters here in the pink. It would have to be, the pinks would all have to be high because we have a low here. So this can no longer be a high number. It cannot be 6, 7, 8, or 9, but then that's not valid. Therefore, this has to be on the loop. So this can't be on this. This still could be on the loop, but this one specifically has to be on the loop because we tried it without being on the loop, and then the problem is it can't be off. We tried it off the loop where it basically counts the number of total cells, and it can no longer do that. So this has to be on the loop, which means this has to be on the loop. So that's pink. You could technically still do that way. We don't know though. This has to be 1, 2, 3, 7, 8, 9 also, because this sees two distinct numbers on the German whisper lines. This is not valid. This could go that way, could go this way. Therefore, this has to go here. Okay. So this, we need a 4 and a 6. We need a 6. So this could be 6, and that would be 1, 1, and 2. Okay. Or this could be 6, in which case it goes there. Oh, that's interesting. So where can the 6 be? This could be 6, which makes that 5. So the 6 cannot be any of these three, right? Because, again, 6 can only be next to one unique digit on a German whisper line. And therefore, it would have to be something like this. Or it would have to be something like this, right? Where it's 161 or 161. But it cannot be here. It cannot be... So then, if it's on the German whisper line, it cannot be here. It could be here. It could be here. So if it's on the German whisper line and this is 6, this cannot be 6 then. The 6 would have to be one of these two. If it's here, this is 6 and this is 1, 1, right? Which would force this to be 2, which would mean you would have to go these two cells as German whisper lines, which means that's not a German whisper line. So that's if this is 6. If this is 6, this has to be a 5. If this is 6, it can't be German whisper line. It can't be on the German whisper line. So if this is 6, it can't be on the German whisper line because it would have to be 161, which is not possible. If it's so, therefore this is off the German whisper line if it's 6. If this is 6, this is 1 and 1, which forces this to be 2, which means both of these are a German whisper line, which means this can't be a German whisper line. And if this is 6, this has to be 5, which means it can't be on the German whisper line. So no matter what, this cannot be on the German whisper line, but we don't know anything about it, really. So this has to be 3 then. So this is 3, which means this cannot be 3, and this cannot be 3. Therefore, we have a 1, 2, 7, 8, 9 set in these 5 cells. So the rest have to be 4, 5, and 6. This is obviously 5, or 4 and 6. This is 4 and 6, and this is 4, 5, or 6. We know there's 3 yellows, and that matches the 7, 8, and 9. It cannot be low, right? If it's low, that'd be 1, 2, 1, 2, and then you have nothing possible. So the yellows now we know are high. So the yellows are high. The pinks are low. So therefore, this has to be low. So this is a 4, and we have a 5 or 6 and a 5 or 6. So this has to be a 9, and this has to be a 9. This has to be 1 or 2. This cannot be 9 here, so this is 1 or 2. No 1 or 2, 7 or 8. This is 6 or 9. It can't be 6 because it must see two unique digits on the German whisper line. So this is 9. This cannot connect to this anymore because it's not 5 away, so that's not on the German whisper line. So this is not valid. So it must go here, which means this cannot connect this way. So this has to go this way. So it has to go here and it has to go here. This sees 1 or 2. We don't know which. This sees 1 or 2, and we don't know which. This is 1, 2, 3, or cannot be 4 because this is not 9. This is 1, 2, 3. This is 1, 2, or 3. Okay. So it could continue here. That's fine. It could go here. That's fine. So this is, we have a 1, 2, 3, 1, 2, 3 set. So 4, 5, 6, 7, 8, no 9. 4, 5, 6, 7, 8. This cannot be 4 or 9. 4, 5, 6, 7, 8. So if we tried continuing this way, it does not. Okay, so this one cannot go this way because this is not 1, 2, or 3. So this has to continue this way. So this goes this way, which makes this blue, and this one can't be. So this is gray. This is 1 or 2. This one could go either way here. So this is 1 or 2. This is 9, which is not the correct value of those on the loop, which is fine. This has 1, 2, 3, 4, 5, so this is fine. This is 1, 2, 3, 4, which is fine. This is 0, which is fine here. This is 1 or 2 again. We don't know which. So this is 3, 4, 5, 6, 7, 8. Okay. This has 1 on this way. Oh yeah, this has to go this way then. So this is high. It has to go this way. So this cannot be 4, 5, or 6 because it must connect with another low. And so that's 2 unique digits that it would be next to. So this is 7 or 8. 5 or 6, 5 or 6. This is 1. It could continue. Okay, cannot continue that way. So if it tried to go that way, the biggest difference you have is 8 and 4, which is not 5. So this is not valid, which means this has to go this way, which means that's not valid. So this is 3 and 8. Because that's the only valid solution there. This can't be 3 or 8. This can't be 8. This can't be 8. This can't be 8. We have 3 here. This is 3. It continues on here. But this cannot go that way because there's no digit that's greater than 5 away. So this has to be a 9. So this is red. It cannot go this way. It can't go this way because it touches itself. So that's not valid. If this is on the line, it could be anything but 1. If it's off the line, it has to be 1. Okay, so this is valid now because there's 0, and this has to be 1 because this is off the line, off a loop, and then the digit counts a total number of loop cells in the indicated direction. So that's 1. This is 2, which makes that 1. So one of these is 3, and it has to be with 8. So this is 7, 8, right? This can't be 7. This is 1 pointing that way. This is 2, that's fine. This is 1, that's fine. This is 4, that's fine. So this is also 4, 5, and 6. This is 5, 6, 7. So this is 1, 2, 4. So this, oh wait, no, 1, 2, 4, 1, 2, 8. Um, hmm. So it could continue here. It cannot continue this way because this is at most a 4, 5, or 6. So this has to continue this way. So this is a high, which makes this a low. So this has to be low, which makes this 8. So this has to be 7 because we can only have 2 and 7. So then that becomes 7. This becomes 8 and 3. This can't be 7. This can't be 7. So it continues on this way. And it could connect this way. We don't know. So this is not valid. This is 1, 2, or 4. Okay. We know. Okay. So if it goes this way, that's a 1. It could go this way. Hmm. Wait, so it's no, if it goes this way, it's 2, 3, or 4. 2 or it has to be 4. Oh, which is not possible. So say it goes this way. This can no longer be 1. So it would have to be a 4 if since this is a low. But the problem is it has to continue on the loop, and then you would have 4 being next to 2 unique numbers on the loop. So this cannot be on the loop. This has to be off the loop, which means this is 1 because it points to 1 digit here. So therefore, this is on the loop in a low. This is on the loop in a high. This is on the loop in the low. This can't be on the loop because it would touch the 9. So then we have goes. Oops, it's not. We want to make it green. So it goes that way. So this is 2, 3, or it cannot be 4. This also cannot be 4 because so this is 2, 3, 2, 3. This has to be 8 because it has to be next to 2 and 3. And that's the only digit that works. It could go back on potentially. Potentially. This is 1, correct, and that points that way. Okay. So this cannot be 2, 3, or 8. So we have a 1 and a 9 here, and one of 4, 5, 6, or 7. This has to be 4, 5, 6, 7. Oh. So then this is 2, 3, and 8. This is also 4, 5, 6, 7. It could technically go there. That's fine. So say it continued on here. Could that work? No. Because where does it go from here? Right? This one goes here, there's no difference of 5. This one goes here, there's no difference of 5. So it cannot continue on here. It has to go down. So this has to be down, which means it's cannot be 1, 4, 5. It can't be a 6 because it's be next to a 1 if it's next to a 6. So this is 7 or 9. It cannot, it could go here. It could go here. Interesting. So if it continued on here, the problem is it would be 1. So this would be high. This would be 1. This would have to be high, which would be 7 or 9. It could not be 6 because 6 would be next to 2 unique digits on the German whisper line, which is not possible. So then this would be 7 or 9. But then this, I guess it could be 4. Hmm. So it could be this has to be 9 and 4, essentially. So either this is 9 and 4 or this is 9 and 4, right? It has to cross sometime. And the only one it can cross to is well, I guess it could be 1, 6, 7. Okay, yeah, that's true too. It can't be 6, but it could be 1, 7. So this is 9, 4, or this is 1, 7, in which case this is 9. Or this is 7, 1, 9, 4. Hmm. So one thing is that if it goes this way, it has to continue on. So if it's 9, 4, oh, this can't be 9, 4. It cannot be 9, 4. And then it can't be 7. So it has to continue on here. So it has to be low here, which means this is high, which means this is low. Yeah, it has to go that way. So the reasoning is if this is 9, this would have to be 4, but then it connects to two different unique digits, which 4 can never be on a German whisper line. So then the same problem with 6. So this has to be a 7, this has to be a 9, this is a 1. So then the 7 can only be in column 9 here. So this is 7. So no 1, 7, 9. This can't be 7, 9. This can't be 7. This is not on the line. This is not on the line. This is not on the line. So this has to be a 2. And on the line. It could extend either one of these. So this can't be 7. To enter this, it would have to enter this way and then exit this way. But that's not possible because that would be 8, 4 at the most. So this cannot be on the line. So this is 2, which means you can't have just 2 on the line. This must be 4 through 6 with the amount on the line there. So 7, 2. It could be 8 here. It could be 8 on either side. Okay. This sees at least 3. So if this is not on the line, it would have to be 3 or 4. So it would have to be 4. So if this is not on the line, say this is not on the line, it would have to be 3 or 4, but the 3 is over here, so this would be 4, which would mean this is the high. So this would have to be 8. Oops. Excuse me. Hmm. Okay. So this is already done. These are all done. Technically, it could go that way. Hmm. So it's really just these arrows that we were worried about. And that mixed with German whisper. So if it continues this way, this would have to be 8. This would have to be 3. 8, 3, 9. But it could just enter in from another way. This has 4, 5, or 6. Oh, that's interesting. Okay. So if it's it could do something like this. That is possible. And that would be 6. Can it ever be 5? Yes, it could be something like that. Or something like that. Or something like that. And it can be 4. So say 6. Let's try 6. So say this was 6. Then it has, it could just be that too. Right? Let's try, let's see, that would be high, low. So this would be, let's try this. High, low, high, low, high, low, high. So this would have to be 7. This would be 2 then, because it can't be 1 from there. This would be 8 or 9. This would have to be 1. It could be 1 or 3. This is 1 or 3. Oh, that's not possible. So it have to include that, because the problem then becomes that this is 1 or 3, 1 or 3. You have 8 and 9, 8 and 9, and none of those are valid. So that doesn't work. So what if we go down first and then go this way? So then this is not, and then this would be high. So this would be 8. This is low, so it's 1, 2, or 3, which works. This is 7 or 9. This is 1, 2, or 3. This is 7 or 9, so this would have to be 9. So we have 9, 7. This would be 1, 2, 3. This can't be 4, so this would be 3, which makes that 8. So then we have 3 here. These would no longer be valid, so this would have to be 3. So that does not work. Okay, so that cannot be possible. But we potentially still could have this work if this goes high, low, high, low. Something along this lines of high, low, high, low, high. And that works the same way whether it's this, whether it's higher, right? Because if this was blue, this was red, blue, red, then blue. If this is red, blue, red, blue, red, blue, it always makes this. So this one's always the same. So this would have to be 7. This would be 8 and 9. This would be 8 and 9. So this would be 9. This would be 8. This would have to be 3. Oh, that doesn't work. Okay, so 6 is out. We can rule out 6. Yay. So 6 cannot be the case. What about 5 and 4? Anytime you start down here and go this way, I don't think that works, right? Because then this has to be 3. So it could go here and then enter. Or it could go here and then enter. So you can never go down now, right? If we try to go this way and then here, so that works because this doesn't have to point to 3 anymore. If we try going down here, once we get here, we have to go 4 or 5. So then this is never part of the loop if that's the case. So it either has, so we can never enter this way and we can never enter this way, right? Because if it, well, this one maybe. It just can't go this way. If we try going this way, you have to go 4 or 5. Because we can't do 6 anymore, right? So because of that, you have to continue 4 or 5. Because you can't go 3 up and then 2 because it touches itself there. So if you start going down, you have to continue going down. Okay, so we know then this is 4 going down. So it's either here, or it's here, or it's here, or it's here. Okay, so then this is always going to be in the loop, no matter what. Even if it goes up there. So if this is blue, this is red, this is blue. Let's continue with just this red. So then blue, red. Okay, so say we didn't have that. Say it went like this. So say it went up, blue. I think it's the same coloring here. Red, blue, red. Yeah, blue and red. Because you always alternate on, it's like checkerboard pattern. You always go black and white, right? And it's always going to be the same. So we know these two have to be on it, right? You cannot have essentially it go down and then continue and then 4. So it is either going down here, starting from here, so that's always 4, or it goes here and then 4. Or you can go here, obviously, in 4, and that works too. So these two are always guaranteed to be on it. So this is always low, which means, and it could be 4. This actually could be 4. And this could be 6, 8, or 9. Because it could go up, and that would be 1 and 1. And that would be one unique number, which is next to. So the 4 could be there, and the 6 could be there. Okay, so it cannot go down, so this is not valid. It could go here, it could go here, right? And that would be 4, which would be valid, which could go that way. Or it could, be lying and be on the loop. Is that possible? So then this would be high. This would be low. This is the minimum. High, low, high. So then this would have to be 7 and 9 and 7 and 9 because, and this would be 7 specifically. So this would be 7, this would be 9. This would have to be 1 or 2, but that's not possible. Ah, you can't do that then. So then you cannot go this way. Even, yeah, you have to either enter, it has to enter this way if it goes here. So it has to enter here, and then like it basically has to, it can't touch there, so it has to go that way. I guess it could go that way though. No, that's actually that's possible too. Let's see what happens there. Oh no, because this is 7. This would be a high, and it would have to be 7. And this would have to be 1 and 2. But it's not possible because 1 and 2 are here. So this cannot be low with a 1 or 2. So this cannot go up and then down. So this is not valid. So therefore we know this is a high. So this cannot be 7, it cannot be 9, it can't be 6 because it's next to a 2, so this has to be 8. So it goes one of these two ways. It could go up, potentially. If it goes down, it could go something like that. That's possible too. And this is 4, and that's valid. But, or like something weird like that. Yeah, that's possible. So it always connects here. This is always 4 or 5. So this cannot be 1, 2, 3, 7, 8, 9. So this is 4, 5, and 6. So this can never be on the loop. Right? If it's on the loop, it's next to 2 digits that are German, that are on the German whisper line, which is not possible for 4, 5, 6. It cannot be 1, cannot be 2, cannot be 3, cannot be 7, 8, or 9. So this is 4, 5, 6. Therefore, this has to be off the loop. Since that's off the loop, this can never be on the loop, so that's off the loop. Therefore, we know this is on the loop. because you have to have four at least, and it's either these four or this four. We don't know which. So this counts it correctly. We know there's at least one going up. So this has to be at least 5. So this is 5 or 6. Could go down, which means that's 4, which is fine. So this is also high. So this is 7 or 9 because it cannot be next to, it has to be next to 2 unique digits. It's either one of this one or this one. So one of these two is valid. If it's this one, it's 3. Oh, that can't work. So it cannot go here and then go down because that would have to be a 3. And we already have a 3 here. So this has to go down. So we know it goes this way, then that way. This is 1, 2, or 3. This is 7 or 9. Okay, so then this is not on the loop. So we know this is 4. So this can't be 4. Because it counts however many valids, so that's 4. This is 7 or 9. 1, 2, 3, 1, 2, 3. It could go here. It could extend. Okay, this is not on the loop either. So it could go here, in which case that's a 3. And this would have to be 8 or 9. Oh, so this can't be 6 either. Because, yeah. So if... If this is low, it's 1, 2, or 3 also, which would make that an 8. Interesting. If it goes up here, this is a 3. So if it goes up this way, this is a 3. It could be next to a 9. So it could that still could be 6. But if it goes up this way, this is 3, which forces this to be... Actually, this could be 8 or 9. That's fine. So this is 4, which is valid. Or it could just continue on, right? 3, then this would be 3, 8, and that would be 9. And that would be 7. 1, 2, 1, 2. Yeah, it seems okay. What could this be? So we have 3, 5, 6, and 9 here. Interesting. So if it goes this way, it has to be 3. It could be 3, 9, 8. Which would make that 3. Okay, so yeah, also these two cannot be on the loop because they touch this. If it goes this way, let's say it goes this way, then this would be 1, 2, 3, 1, 2, 3, 1, 2, 3. So that would be 8, which makes that a 9. And that is 7. Oh, interesting. That wouldn't work. Okay. So say it went this way. If this was a blue, this would be 1, 2, or 3, which means this is 8. That forces this to be 9, which forces that to be 7. And this 7 can only be next to 1 and 2. So this would be 1, 2, 1, 2. This would be 3 then. But this is the 9. And then you have 3 and 9 in this spot. So this cannot be valid. Therefore, we know there's 4 valid numbers here. So this is 4, this is 4, this is 4. It has to go up, so that's a blue, which makes this a 3. So this cannot be 3. This can't be 3. It could go this way. It could go this way. We don't know. So that's still 5 or 6 is still valid. Um, If one of these is 3, this has to be 9. And this is 9, this is 8, but that would eliminate both possibilities of 3 and 8. So this could not be 3. So it's 1, 2, 1, 2, which means this has to be the 3, and this has to be the 8, because there's no other place for 3 in row 9. So you have 1, 2, 1, 2, which 1, 2, 1, 2. So this cannot be 1, 2, 4, 8, or 9. So this is 3, 5, 6, and 7. This cannot be 1, 2, or 7, so it could be 3. This can't be 4 here. So this is 4, 3, 4, 5, 6, and then 8. So 8 could be here, here, 5, 6. 8 could be is either here or here, and then 9 can be one of these two. Okay. So let's see. Then this cannot be 1 or 2, 4 or 8 or 9. So it's 3. Can't be 3. It's 5, 6, 7, right? No 1, 2, no 3, 4, no 9, no 8. It's 5, 6, or 7. So 3 is one of these two. So this can go one of those two spaces. It cannot go up. If it goes up, this is a 7 at most. So this cannot go up, which means it has to go this way and be a 9. So this is 9, this is 8. This cannot be 9, so this has to be 9. Because the 9 is eliminated here, and these are only two spaces. This has to be blue. So it goes this way. So this cannot be 4, because it either goes that way or that way, and it's these two numbers. So this has to be a 2. It could go here, and that would be 7, so that's valid. This sees 6 numbers on the loop, so this is a 6, this is a 5, which means none of these can be 5. So this is 3, 6, 7, which means this is a 5. So this is a 6, this is a 6. This becomes a 5, this is a 6, this is a 5, this is a 4, this is a 6. So this is a 6. No 6 here. It can't be 6 here. This can't be 6. This is now a 3. So this is not on the loop. This can't be 3. No 3, 5, or 6. So it's 4, 8, and 9 here. Okay, so this is 6. This becomes, what, 5 and 7? And this is 1 and 4. So it cannot go this way because it just goes to a 1, 4. So this has to be high. So it cannot go here. It goes here. So this has to be 7 or 8. This becomes 1, 2, and 6 or 7. Right, so this can't be 1, this can't be 6. This is 1, 2, no 3, 4, 5, no 6, 7. This could be 3, 4, 5, 7, 8. 3, 4, 5, 7, and 8 could be here. Oh, 8 can't, well, 8's one of these two. So no, could be 1. So 1 would be one of those two. 2 cannot be here. 3 cannot be here. Could be 4, 5. 6 could be here. No 7, no 8, and 9 could be here. Okay. So say it just continued on to here. Well, this could be valid. Hmm. It could do something like that. I don't know how valid that would be, but it could. Um, we've got all of these accounted for. This is 2. Oh yeah, we could have figured out it was both of these because this is 2, and it can't be. That would, if only one was on there, it would only be that, right? That would be incorrect, or it would not be lying, which would have to lie. If this is 1, it has to essentially go back here, right? And enter here. So this would be 1. This would have to be 2 or 4. It cannot be 4 because this would be 8. Okay, so this can't be 4. So this has to be 1 or 2. And it either goes this way, in which case it's 7 or 8, or it goes that way, in which case it's 7. It cannot, well, it could be, no. It cannot enter here. So if it tries entering here, then where does it exit to? I guess it could exit that. No, it doesn't work. It has to go to one of those two. And then if it's 3, this would be between a 7 and an 8, which is not possible because 7 and 3 are not 5 away from each other. If it goes this way, again, it would have to be 7. And again, that would not be possible because you have no 3 and 7. So this cannot enter this way. So this is not valid. What about this way? So this would be high. This would be low. So it'd be 1, 2, 1, 2, and that would be 7. So that seems valid. This is 4, this is 5, this is 8. Yeah, so this seems valid if it goes this way. What about entering this way? This would be 7 or 8. This would have to be 1. So 2, 7, 8, 7, 8, 1. Excuse me. So yeah, if it went this way, this would have to be 7 or 8. Which means this is 5, this is 4, this is 3. 7 and 8, this would have to be 1. But could it continue this way? I don't know. So if this is 1, this can't be 6, it could be 9, but the problem is 9, then 4, and 7, 8. So it cannot go this way. Can it go this way? I don't think so. 1, 8, 4. No. That just doesn't work. So 1, 8, 2, 7, 1, 8 or 9, but then that would be 4. Yeah, so it can't go this way either. And then I'm pretty sure it can't go this way. So we have 1, 8, 2, 7, 3. No, it can't go this way. Yeah, so it has to go this way. So then this becomes blue. This is red, which means this is a 7. So we have a 7. This is not a 4 or 5 or 7, so this is 1 or 2. This has to be 8. So 7 can no longer be here. 7 can't be here. 8 can't be here or here. This is a 5. This is a 4. This is a 1. This is a 7. This can't be 1. This can't be 1. So this is 4, 5, or 6, which means that it must enter this way. It has to be 3. It could be 3 or 2. So this is 4 or 5. So we have a 4, 5, 4, 5 pair in column 3. And there cannot be a 4 or 5 anywhere there. So this is 9. This is 6. This has to be 4 and 9 and 8 because of Sudoku. This is a 2. No 6, no 4, no 2 here. So this connects this way. This cannot be, well, maybe it could be. Okay, so, ooh. Okay, let's go back then, because we did not take into account the possibility it could enter this way. Oh no, it can't enter that way. If it goes this way, then it has to enter that one, which touches itself. So this cannot be. Yeah, so this is actually still valid. which means we're going to do Sudoku again, which is 9, 6, 4, 9, 8, 2. No 4, no 6, no 2s. So then we connect the loop. We continue coloring. These can't be on the loop. This has to continue on this way, so it's there. It cannot continue that way, so it has to go this way. So then it has to go this way, which means this is not on the loop. These are not on the loop. And this is the loop. So then we know there's exactly 5 here. So this is 5, this is 4, this is 5. This has to be low, or this has to be high. So this is 7. No, it could be 6 or 7. So this is 6 or 7. This has to be 1. So this is 7, which makes that 6, which makes that 1, which makes that 2, right? This 6 can only be next to a 1. So that's 2, this is 1. This is 6, this is 1, this is 2, this is 7. Oops, that's not 7. This is 7. This is 5, 3, 5. And we're just doing Sudoku. 2, 3, 7, 4, and 3. And that's a solution. Yeah, I must admit, I love these type of puzzles. I love these having loops where you have to deduce what they are and where they basically come from. And then the loop rule will basically determine a lot of how you can put things, where you can put things. And it did in this one, because this was German Whisper. And I like the interaction between the loop and the German Whisper very much with the arrows. Anyways, I hope you enjoyed it too. And I'll see you next time on Frank Puzzles. Take care.